So here we're going to introduce another piece of syntax here, which is called exception handler. For example, the exception handler is going to say, let's try this. Let's try to run this method. If everything goes well, that's going to be the end of the story. We're going to get our transaction ID and return it from process transaction. That's going to be the end of the story. Otherwise, if exception occurs, we're going to catch it. That's the syntax. And we have to specify which particular exception we would like to handle here. And we're going to say that overdraw exception is the one that we want to handle. So this is the syntax, which is going to say that if exception occurs, we want to catch it here, which means handle the exception, part of the process transaction. And what we're going to do is that we're going to say, well, I guess my plan was probably just to print a message, but let me double check here. Yeah, I can just simply type a message here, system.out.print line, and print a few things. First of all, I would like to say sorry. Sorry, the amount is too big, right? So, or whatever, and we can basically print the exception get message, print message, and we can also print exception the amount, right? So overdraw amount is this, something like that. How about this? If I just say sorry, there was a problem, right? And so then the exception class will tell us what the problem is. Just print the message and print the overdraw amount, something like that. Okay, so this is the handler, and I can also strongly recommend us doing something like this. Finally, and in case of finally, I just create another block and simply move this return statement into the finally block. As you can see, transaction can significantly alter the flow of events inside of our code. This is the proposed object-oriented approach to handle significant errors. And what happens is that there are basically two alternative paths of execution. One is normal, right here, and another one, the alternative one, where we print an error message. At the same time, there could be actually restart this so I keep track. So there could be things such as open database connections or open files or some other resources allocated in terms of some big objects were perhaps created and we want to dispose of them. Any other type of resource allocation should be placed in the finally block, because if you open the file, transaction has failed, you still want to be able to close the file. So the finally block is the place to handle resource deallocation and any kind of cleanup. In my case, I don't have much to do because I really didn't dynamically allocate any resources or work with a database that I still have to maintain, perhaps, even if the exception has taken place. But my return statement can be placed in the finally block so that it returns the unconditionally returns the transaction ID. And in this case, well, perhaps zero, transaction ID 0 will be, we can document this fact that in case if the transaction fails, transaction ID, return transaction ID will be 0. So let's take a look at the main application this time. And so it just still says process transaction, and it will print transaction ID, and this will be printing the remaining balance as well. So let's try to run this application with those new changes. And so first of all, let's test the normal case, which is like if I want to withdraw like $20, right? So I get $80 and remaining balance. That's expected. And I generated this transaction ID. So if I run it again and say $200, right? So it prints, sorry, there was a problem, overdraw amount is minus $100, and transaction ID is 0, and the remaining balance is $100. Okay, given all this, let me record this this segment first.